listening to Proof Text, a Glossa House podcast by Dr. T. Michael W. Halcomb, Dr. Frederick J. Long, Dr. Mario Melendez, Dr. Jennifer Noonan, and J. M. Smith. Welcome and enjoy.
Hello and welcome to Proof Text. I am Michael Halcomb, and in this episode I'm thinking about three things, and I want to share those with you. Actually, I'm really thinking about one big thing, but we'll break it down into segments. And the one thing that I'm thinking about has to do with Greek papyri and ancient Greek fragments. I remember when I was in Kentucky years ago, in fact, studying at the University of Kentucky, that this news broke that I think the professor's name was Brent Seals or something like that, had used technology at the time to sort of decode a scroll that was rolled up. So they used computer technology to look through each of the layers to sort of decipher what was in this scroll because they couldn't unroll it. If they had unrolled it, it would crumble, it would break. So since then, over the last decade, technology, of course, has gotten a lot better. And I saw an article a few weeks ago come up, and I'm going to share that with you here. It came out of the University of Kentucky, and the title, as you'll see if you're watching, says Breakthrough, Discovery Made from Within 2,000-Year-Old Herculaneum Scrolls. And so this is referring back to the same scrolls that I think it's referring back to the same scrolls that I had read about years and years ago. So anyways, yes, so it's talking about Brent Seals. He's a computer science prof at the University of Kentucky. He hosted a conference and a live stream at the University of Kentucky back in October, and they presented this breakthrough announcing that an entire word has been read from the still closed scrolls, right? So they got a word. So this is pretty interesting. And the Greek characters, porphyros, meaning purple dye, porphyra, is the word that they were able to uncover. So this, I'm thinking about, as I read this, I'm thinking about what kind of technology were they using to do this? If you go back to years ago, they were using X-ray images and all kinds of things. But one of the technologies now in use is called DeepMind. And so DeepMind has this new AI model that helps decipher, date, and locate ancient inscriptions. It's pretty amazing. And here's another article that I'm showing on the page right now. This is by James Vincent, and it's at theverge.com. So there's a lot of Greek scholars that are interviewed in this, and they have some interesting GIFs or GIFs and things like that on here. But what I really want to draw our attention to is the software that they're using. It's open source, it's online, and it's called Ithaca. And so we can go to that and check it out. And what I'd like to do here is just try to give it a test run. The idea is that if we were to find a fragment, we could use this software to help us reconstruct what the fragment would say as a whole. It would help us date it and even help us identify geographically where it was from. That's pretty incredible if you think about it. So let's give it a test run. So if you go to ithaca.deepmind.com and you enter at least 50 characters, and then you can do a search. So I'm going to do that here live with you. And one of the things that I thought would be interesting to look at and try to reconstruct was Papyrus 52. It's one of our oldest pieces of papyrus, one of our oldest fragments that we have. And as far as we know, it's from the Gospel of John, chapter 18, verses 31 to 32, somewhere around there. So some date it to 125 to 175 AD or CE, and it's found in Egypt. So what I want to do is just grab that text, and how I'm gonna do that is I'm gonna go to the GreekCNTR.org, and I've already got John 18:31 up, and I'm gonna click the P52 witness, and it's going to give me the transcription there. Now, if you're seeing the screen, you can see that the highlighted letters are what's missing. The letters that are unhighlighted are what's there on the actual piece of papyrus. If I click this little magnifying glass, we can see that. So, for example, we can see here on the second line, I'm going to pull this up, we can see Udena. We're looking at the fragment now. And if we go back to the transcription, we can see that Udena. So what's missing is everything that's highlighted here. All right, so what I want to do is give this a test, and we're gonna see if we can make some of this work. And yeah, so let's do this. We'll copy some of this, and then I'm gonna bring it back into Ithaca, and I'm gonna paste it in. All right. So we got this in Ithaca now, part of 31, verse 30 of John 18:31, and part of John 18:32. And what I'm going to do, because at Logos 2 is where it begins, I'm just going to start plugging in question marks, and that's what it's going to help fill out here in just a moment. So we have the two Iesu, and then so I'm just filling in different blanks here, and I get up to 10, and it wants me to enter at least 50 characters, so I'm going to grab a couple more words. On Ibn. All right, let me paste this in. All right, this is pretty amazing. Keep going here. Oops. Give me a moment, hang with me. I think you'll find this interesting. All right, so we got 50 words in there, and give me just a second. So this is more helpful if you're watching, so you can see the magic happen. We're gonna have it try to reconstruct what we have here. One more second. All right, so it wants me to enter a few more characters. Let's do that. All right, so I think I got it ready to go there. Now what I'm going to do is I'm going to hit restore and attribute, and we'll see what this does. So it says restoration can take up to 15 minutes. We'll see what happens here. This seems to actually process pretty quickly, but it says Ithaca is trained on 78,608 inscriptions. So it gave me my attribution outputs already. That was super quick. I'm going to click view. And you can see that it's given me a geographical attribution hypothesis. And it's saying that this, whatever I just typed, was likely to come from Syria and Phoenicia. So that's kind of interesting. So it does give us a potential, some potential stuff in Egypt as well, but the probability for Syria and Phoenicia is a little bit higher. So let's see if it's still working here. All right, it's still going, processing the restoration. So that's the geographical attribution saliency map. And if we look at the chronological attribution hypothesis, it's giving us really a date distribution of about 10 years, 160 to 170, which is pretty fascinating because most people date this 125 to 175. So this is putting this on the later end of that. So it's saying that there's a high chance that this was written between 160 to 170. All right, my outputs are completed. We'll look at those in a minute. But there's almost just a high chance that it was written around 100 to 110. So this has nailed it as far as what scholars have suggested, 100 to or 125 to 175. So it really has nailed it. It's given us a range of 100 to 170, essentially, for the highest degree of probability. It's telling us that it's likely from Syria and Phoenicia or Egypt and Nubia. So again, it's very correct in that regard. Let's see what it gives us for our output, the restored output here. So here's the restoration outputs, and you can see that based on my text, it gives us numerous possibilities for what this looks like. About 20 there, and then down below it gives us a restoration saliency map, and it's telling us what it did for when it placed in a letter, like where it put that. So if it's dropping in an iota, then it's showing us where it did that. So if we go back up and look at the first one, the first construction, we have udena, and then it says in. So that might have been an error on my part. I didn't put a space there, but it says ine. So maybe that's an error. But then we have oloyi, which we know it should say ologos. So it didn't get that right. It should say ologos. But here we have oloyi. And then it put the eplerothe. Let's see, it got that right. It nailed that. Semeno thanato. It nailed both of those. Semeno, and then it should say puo thanato. Semeno puo, but I left the puo out. So it nailed that as well. So the reconstruction of the text was actually very good. The dating of the text was very good, and the geographical pinpointing of the text was pretty good. So yeah, I'm thinking about the geography. My three things, I guess: the geography, dating, and reconstructing or restoring of ancient Greek fragments, manuscripts, papyrus fragments. This is pretty incredible stuff, and I'd encourage you just go play around with it. Ithaca.deepmind.com. Ithaca.deepmind.com, and you should have some fun with that. Use the GreekCNTR.org site. You can play with that, but technology is amazing at this point, and I want to encourage you to use it responsibly in your own Greek studies and Greek research, but pretty cool stuff. Maybe you'll be the next one to come up with some breakthrough. So I'm going to stop there for now and say I hope that helps.
Interested in growing your ancient language skills but not sure where to start? Glossa House can help. From illustrated readers and short stories to lexicons and grammars, Glossa House offers a variety of resources for beginning, intermediate, and experienced ancient language learners. Head to glossahouse.com today. Glossa House, language resources for the global community.